Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is a mixed bag of possible exam questions, round 3, question 3. The formulas used are included in the video. The question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP examinations and past papers, do not appear in most textbooks or even the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. Okay, our first question. Our question states, a steel pipe having an inside diameter equal to half the outside diameter is used as a cantilever with a length of 2.5 meters. It carries a uniformly distributed load of 20 kilonewtons per meter over the first 1.25 meters from the fixed end, as well as a concentrated load of 2 kilonewtons at the free end. The deflection of the free end is limited to 7 millimeters. The modulus of elasticity for the material is 200 gigapascals. Calculate the following. Question 1. The required dimensions of the pipe. Question 2. Choose the lightest taper flange eye profile that can replace the pipe for the same deflection limit. Question 3. The maximum bending stress of the selected eye profile. Okay, now what we're going to do is answer the first question. Our first question states they want the required dimensions of the pipe. So, what we're going to do is first put our information up, and then we're going to do our formulas. So, L1, 1,25 meters, L2, 1,25 meters. Now this will be force equals 2 times 10 to the 3 newtons. Weight will equal 20 times 10 to the 3 newtons. Deflection, YT, is equal to 7 millimeters, which is 7 times 10 to the minus 3 meters. And also our GPA, E is 200 times 10 to the 9 pascals. Now, what we're going to do is they want us to calculate the required dimensions of the pipe. So, first thing to do is we want Y1. Y1 equals, this is the formula for Y1, W L to the 4 over L1, to the 4, 8 E I, plus W L 1 to the 3 times L2 all over 6 E I. Now we're going to put in our values. So, first things first, W is 20 times 10 to the 3 times 1,25 to the 4 over 8 times 10 times 200 times 10 to the 9 times I. We do not have I, that is exactly what we are looking for. So W is 20 times 10 to the 3 times 1,25 cubed times 1,25 all over 6 times 200 times 10 to the 9 times I. So the next part is we put all this into our calculator. Equals 30, 518 times 10 to the minus 9 all over I. Right, so plus 40, 690 times 10 to the minus 9 over I. Now we add these together because I and I can add. Our denominators can add. So what we are left with is our answer of y1 equals 71,208 times 10 to the minus 9 over I. That is y1. y1 71,208 times 10 to the minus 9 over I. That's important for the next step. Now we're going to do number 2, y2. Now we're going to do y2. y2 states FL cubed over 3EI. Okay, now what we're going to do is say 2 times 10 to the 3 times 1,25 cubed over 3 times 200 times 10 to the 9 times I. Right, and our calculation of y2 is 52,083 times 10 to the minus 9 all over I. Okay, so y2 equals 52,083 times 10 to the minus 9 all over I. Now, our next solution, our next sum, is we have yt equals y1 plus y2. Now we are looking for the value for I. So yt equals 7 times 10 to the minus 3 equals 71,208 times 10 to the minus 9 over I plus 52,083 times 10 to the minus 9 over I. Now to make I the subject of the formula, all we have to do is combine these, and that'll make it I, and then bring I up and 7 down. So 7 times 10 to the minus 3 times I equals 71,208 times 10 to the minus 9 plus 52,083 times 10 to the minus 9 all over 1. Now what we're going to do, we're going to take the 7 times 10 to the minus 3, and that'll be I equals 17,613 times 10 to the minus 6 meters to the exponent 4. So I 17,613 times 10 to the minus 6 meters to the power 4. Okay. Now that we've calculated I, we can calculate our D's. So I equals pi times D to the power 4 minus D to the power 4 D to the power 4 all over 64. Okay, now we are going to make little d the subject of the formula. So, as we know, our d is equal to 2 little d. So, what we're going to do is say I equals pi times 2 to the 4 d to the 4 minus d to the 4 bracket all over 64. Now 2 to the 4 is 16. 16 minus 1 is 50. So pi times 15 d to the 4 over 64 equals I. Formula manipulation, we're going to get little d on its own. So I times 64 divided by pi times 15 equals d to the power 4. Now, what we're going to do is say the fourth root of I times 64 over pi times 15 equals d. Right, and now we put in our values. Now I'm going to write here I equals 17,613 times 10 to the minus 6 times 64 over pi times 15, the cube root, the fourth root, and that equals d, and d equals 0,06998 meters, which for ease of calculation purposes is 70 millimeters is D. Now big D is 2 times D. So big D equals 140 millimeters and little d is 70 millimeters. Question 2.2. Now what we're going to do is state that 4i equals 17,613 times 10 to the minus 6 meters to the power 4. Right, we're going to select 203 times, this is for the flange, this is for a flanged I-beam. So 102 times 25,3 kg per meter. That's the selected I-beam. So now we're going to work out the stress in said selected I-beam. So what we have, 2,3. So we need M equal FL plus WL squared over 2. Okay, M, let's put in our values. 2 times 10 to the 3 times 1,25 plus 20 times 10 to the 3 times 1,25 squared all over 2. So now what we have is M is equal to 20,625 kilonewton meters. Right, now we need our stress. So stress is equal to M over Z. So all we have to do now is say stress is equal to 20, 625 times 10 to the 3 all over 226,1 times 10 to the minus 6 all equals 91,221 megapascals. And that is the finish of it. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comment section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.